let's go to our topic. So yesterday we discussing in the DC part, right? So again, I want to discuss from DC section because of interruption. So are you able to see my screen, team?
Yes.
Okay. So this is my CRP panel. So in the AC circuit, we are having only one AC because that AC supply is required only for the lamp, for the socket, and for the thermistor, for the temperature, for temperature cooling, anything that matter to get to know the temperature inside the panel. And now come to this, the DC supply. The DC supply is required for trip coils, for Ethernet switches, for breaker trip circuit supervision relays, and for the master trip relays, LBB relays. So every relay and contactor or coils required this DC supply. So these relays are very important for a protection. So we have to provide a good, reliable DC source here. So two DC sources we will consider here. So one DC source is coming from the DC distribution board, and the other DC source is coming from this DC distribution board too. So these are pulling. So I am taking, let's see. This is my DC1. This is my DC2. So this is my load, suppose. What I am doing is, I am connecting this one to here, and this is the load 2. I am connecting this source to this loads. So these are some X loads, these are some Y loads. Okay, the DC, these Y loads are fed from the DC2, and these X loads are fed from this DC1, right? Now, there might be a chance of failure of this DC supply. If the DC supply is failed, then these loads are not able, not getting the DC supply. So the relays which are connected to these, the coils which are connected to this will not function. So what I am doing, I am giving a supply like this. So with the help of some switch, here one switch will be there. So generally it will be closed always. Generally it will be closed. So this will be open, right? And similarly, again, I am having a again for this. So this is open. These are the two switches. Generally, this is closed. This is open. This is the how it looks. Now, in a general, this supply is feeding to these loads, and this supply is feeding to these loads. Suppose this is failed, then this DC source, this will be opened up, this will be closed. So this DC supply is coming to this. It's giving to for both the DCs. So this whole part we will call as a changeover relay. The DC changeover relay will take action here by changing the two DC sources if any one of the DC failed. So to continuously monitor this DC supply, we require a supervision. That is a DC supervision relay that is continuously monitoring. If the supply is failed, then the DC changeover relay comes into the action, and it's feeding the supply. So these contacts will open up, these contacts will be made. So this DC supply is routed to this. So these DC supply, two DC supplies are extended to the breaker closing circuits, BCPU, all these relays. Here in this page, you can see only one box. So it seems that there is no interconnection cables from one panel to other panel. This page is only talking about inside the control and relay panel. Before pages, this page is talking about the control and relay panel as well as the DC sub DBs. DC sub DB1, DC sub DB2, and we have to lay a cable between the DC sub distribution board and the CRP panel. So this cable between the two boxes, if we see two boxes and a connection between this, so we have to assume that this is in our scope. But inside the connectivity all will be in the scope of manufacturer, OEM. So this is the DC supply. This is also DC supply. And the next one is the PT distribution. See how the PT supply is distributing. So we are having two connections, two PTs, right? Two cores of PTs. One is for metering, one is for protection. So this is the metering. So again, this is a distribution board, PT distribution board. From this PT distribution board, it's connecting to the TVM. If you want to know the metering, it should be represented with ET. E represents a PT signal. E represents the PT signal. And this is also connecting to E to TCPU and BCPU. Next. So if we are seeing the PT signal, now let's see the CT connections. The CT also the supply to be given to the CRP, right? So this is the CT which is connected to the CT junction box, and from the CT junction box to the CRP. How it is connected? Let's see. Mine is here. If you see D, D represents metering P. C represents protection CT connections. D represents metering connections. So that's the reason you can see here a class 0.2s, ISF less than 5. So for what it is applicable? For the metering, right? So it is a metering core. From the metering core, I am considering P1, P, all these sides of this one, P1 is earthed. The P2 is connected. The P2 is connected. And this is the terminal box inside the junction box, inside the CRP panel, and then to the test terminal boxes, and hence to the TVM. And if it is required, it's going to the other parts. You can see this where it is going. Refer 20 page 4th grid. You can find this, it is connected to that. So this is the CT metering connection. And this is the next page tells about, talks about a CT protection connection. So 5P20. So I said C. C represents protection. A ferrule C represents protection. So this is a protection. Protection which is should be connected to the relay. In our case, the relay is inbuilt feature of BCPU. So I'm directly giving this one to the BCPU. That's it. In the above, BCPU is having metering, and also it is having TVM is also there in the control and relay panel. So I am giving a connections to TVM as well as for the BCPU. So these are the connections might going to the BCPU. And this TVM is also required PT signals, right? So the PT signals is coming from the previous page, 17.2. This is the 18th page, 17.2. These PT signals are coming to here. And these are also connecting to the metering to calculate the active power, reactive power, everything, and the phase angles. So E represents the PT cables, D represents CT metering cables, and C represents protection CT cables, H represents AC cables, J represents DC cables, K represents control cables. Please remember that identification. Again repeating, H represents AC cable, J represent DC cable, K represent control cables or indication cables, E represents PT cables, D represents metering cable, C represents protection CT cables, D represents metering CT connections, C represents protection CT connections, E represents PT signals. Okay. So this is the CT circuit. And this is the BCPU where I said to you, right? The PT signals and CT signals are connected to the BCU for the metering. BCU is also having the metering. If you refer our block diagram, in the first pages, I have shown that the CT metering core and protection PT metering core are connecting to the BCPU as well as to the TVM. TVM also we are having. So this is the BCPU metering connections from the CT and PTs. So these are the PT because of E, and these are the CT connections because of D. metering CT. Next, so now the CT, PT circuits signals came into the control and relay panel. So now I have to bring the indication signals. So again, this is the control and relay panel. What indications you need? What are the indications you need? So that this data we will give at the stage of engineering only time. When we are awarding the contract to the Siemens or ABB, we will provide these list of indications I required. So it's typically depends on the project, depends upon your company policies or your way of design. So in this, we follow these or the standards we require. In some projects, they are not having these standards. So it's totally your wish. I want, these are the indications I am asking the manufacturer. I want breaker close indication, breaker open indication, whether the breaker spring is charged or not, whether the breaker motor supply MCB trip or not. So these indications I'm asking the for the manufacturer. I want these indications that should be displayed on the SCADA. So these are the binary inputs. So how he will get this indication? So he has to integrate this connection with the breaker connections. So this is the block. You can see 52, which represents the breaker. So to prepare this scheme drawing, what we required? We required breaker, isolator, CTs, PTs, manufacturer drawings. So if you just see our breaker, this is the breaker. So let's see what I want. I want close command. I want open command. I want whether the spring is charged or not. And all these things I require, right? So let's see breaker close or open. So these are the indications for the breaker close or open. 353, 354, 355, 356. These are the indications. And this is for the spring charging. So they same was mentioned here. 353, 354, 355, 356, 351, 352. And if you want spring charge motor supply fail, so it's a supply fail means how you know? From MCB. And DC supplies also from MCB, right? Let's come to the MCB. 418, 419. And DC supply MCBs. 411, 410. DC supply 2. 414, 415. So these will be there here. And I also want breaker local indication and close remote indication. So for that also you can take from here. Whether the breaker is in local mode or remote mode. So where you can see that this is the local remote switches. You can take these switches from here. 407, 408, 405, 406. This is the indication I am getting to the breaker. And similarly, I want to know about the status of isolator, whether the isolator is closed or open. So these details I am getting from the isolator drawing. From isolator drawing, we will see whether the isolator closed from their context. I am giving the connections to here. So similarly, all the connections, all the isolators, breaker, earth switches, indications are explaining in these pages. This is also isolated indications. Isolated indications. So by this, all the indications appeared in my SCADA. Now I am moving to the next part, which is protection. In the protection, any relay is operating. Suppose any relay operates, it has to give the command to the master trip relay. So master trip relay will give the command to the breaker to tip, right? Because we are having so many relays. But in our case, the relays are inbuilt feature of BCPU. So a BCPU binary output, if my BCPU given any output, this will make and the supply is extended to the master trip relay and my master trip relay will operate. And suppose tomorrow you just want to add one more relay which is not inbuilt feature of BCPU, so that you can be enabled here at a parallel. If this comes, master triplet should fail. It's again, if you are making a parallel, it seems paralleling means or condition. Series means and condition. So anyone is on, anyone is make, any one of the contact is make, I am operating the master triplet. Right? These two. And these two for the reset. These two for the reset for the master triplet. You can reset from the push button directly inside the relay, or you can reset from the BCP. And this master triplet relay also have to continuously monitor, right? So that is a continuous supervision, trip circuit supervision for the master triplet. 186. This is the master triplet. After that, I am looking into the LBB triplet. So LBB triplet also same. If it is operate, this will operate. So these are again same. But you can see a parallel connection is there. Why this connection? Because this is a trip bus which is going to the adjacent panel. Any one of the breaker is failed in my adjacent panel. On the LBP trip, it's a LBP type of protection, is a local breaker backup protection. So if the breaker is not operated, all the breakers of my feeder should be operated. So that is a signal. If this LBP is operated, then this is giving a trip to all other relays. That's for the parallel connection. So it's going to the adjacent panel. Means next panel, second feeder. Right. And so LBB master triplet fine, completed. So let's now talking about the breaker closing and tripping circuit. See, I said we discussed it. The breaker, to close the breaker, we should follow, satisfy some conditions, interlocks. So those conditions are under, right? So those are placed here in series. 186, master triplet supervision, trip circuit supervision, trip circuit, supervision relays of LBP trip relays, and future use. If you want to add any interlocks, you can add like isolator, everything. And these are again some 196 trip circuit supervision relays and BCPU outputs. If you are giving the closed command, then and if you are tripping the close from this, then only the breaker will close from this. Or else you can close this from the TNC switch, which we have seen in the first few pages of the control in relay panel. There we are having one switch, right? So if you close that also, it directly giving the command without interlock. You are bypassing all this. And for the trip, there is no interlocks, only TN switches. If you are tripping that, otherwise this should be on. This should be on. And for the breaker local interlock, so it's checking that whether the isolators are closed or open. And the next, this is the breaker trip circuit supervision relay circuit. So the supply is coming, and it is this is the post close supervision, and this is the pre close supervision. This is the post close, and this is the pre close supervision. Perfect, both trip circuits. I will discuss this supervision relay in our next session. We will talk in detail on this. And next, coming to, these are the indications, or like suppose if you want to operate this from isolator, so that is a signals for the isolator, common. If you want to close, open, permissive, interlock from the PCB, soft logics for the isolators, for the switches, for all the isolators and the switches. And the last pages will show you that contact multiplication relays. Contact multiplication relays is, suppose this coil is enabled, so it should give to command to suppose X number of I have to use this contact in X various places. So then you are placing this type of contact multiplication relays. So this is the contact multiplication relay. So this here in this page, we are talking about the contact multiplication relay stream. So the breaker trip circuit multiplication relay. Suppose this coil is operated. So this status I want to use at some various places. So these are the contacts. If this coil is energized, then these contacts will make, and if the NO contacts are there, NO contacts will make and NC contacts will break. Such kind of. So this is about the contact multiplication relay, where you can see then you get the output from the BCPO. Then this relay is operating, and this relay is operating. So it is giving the command to this. If you just want to know this, go to the 31st page and look at the second grid. Similarly, from. Yeah. So this about, so after this is the general schematic drawing. And if you just scroll down, you're moving to the circuit 2. Again, all the same thing will be there. Because two circuits are given in one feeder panel, one control and relay panel, because in the context of optimization. In the context of optimization. So now let's talk this. The same feeder 2 is also same. So when you are reviewing the schematic drawing, so what things to be keep in the mind? One is whether the logic derived for my SLD from the SLD is fine or not. The next, we have to check whether the interlocks mentioned are right or wrong. The third, the first circuits, the AC circuit and the DC circuits. In the DC circuits, whether he provided the DC connections for all the coils or oils and the relays or not. And in the fifth, PT distribution circuit. In the PT distribution circuit, whether he done the wiring exactly how we provided the PT drawing or not. So we are providing the PT drawing and distribution board drawings. Whether he is taking the connections from the exact point or not, and the CT connections, and then indications, whether he providing all the indications what required or not. So what we shared at the beginning of when we are quoting when we are giving the quotation, when you giving the quotation across the table, we are providing some status indications, whether he implemented all the status indications or not. And then we are also looking into the control indications, and followed by master AAA circuits, LVP AAA circuit, and breaker closing and tripping circuits, breaker pre and post close supervision, trip circuit supervision circuit, and followed by again the indications, the output indications from the isolators and the switches, and the contact multiplication relays. So every scheme drawing, so whatever the scheme drawing you consider, suppose could be for 33 kV per sectionalizer, coupler, whatever it may be, this would be remains same. So this is a standard. So if anyone asks you what are the things you are doing in the schematic drawing, so we are reviewing the schematics with respect to the protection philosophy what we adopted, and also with respect to the vendor drawings, the final vendor drawings, and also what controlling or indications we are providing. So mainly, again, just I want to repeat, the AC circuit, DC circuit, PT circuit, current transformer, CT circuits, and indication circuits, and master trip relay, LBP AAA circuits, breaker closing and tripping circuits, breaker pre and close, circuit pre and close supervisions, and isolator control and indication parts. So these are the things we can see in the any scheme drawing. These are the common things. And I already told you how to review. So coming to the review part, you have to look into, suppose, let's talk this. So this is the one output. So when a binary from the BCPU, from BCPU, if BCPU give the signal, this will make, if it make, then it giving a command to the trip contact multiplication relay 152T. So this 152T, where I am using this, go to the page number 28. Go to the page number 28. Yeah, I believe this is the page number 28. So he used it here. Because if that came, so my breaker will trip. Because my relays are all the inbuilt feature of my BCPU. So if my BCPU give the command, then it is getting, it's giving the command to the client. So in that way, we have to see. Or else you can see here also. He's saying that 152 is a contact. If we want to know this contact, refer 32.3. Go to the 32 page. So this is my page number 32. Where is the grid 3? This is the grid 3. Come here. So here you can see 1213. So this is concept. This is a general review of the schematic drawing. And if you see from the last pages, you are only seeing the K. Why? K represents control indications. All K only. All these are K only because of controlling parts and protection. Again, repeating. This is a very important when we are doing the cable schedules. H for AC cable, AC supply. J for DC supply. K for control. E for PTs. D for metering CTs. C for protection CTs. So this is about the schematic drawing. And if you want to know, so let's see here. This is my circuit. A supply, this core one is given to the BCPU. Fine, this is a protection. If you see the metering, it is giving to the TVM and also to the BCPU. And this BCPU is also getting the supply from the protection PT also. Right? So in that way only we are preparing the schematics in the next phase. The logic first we have to develop. Based on that, we are preparing. So these drawings generally prepared in the E3 software. It is a similar kind of AutoCAD, but it is having some intelligence inside. It's having inbuilt intelligence. Suppose if I am connecting this suppose let's see, if I am connecting this one to any, if I return here 16.2, so it will give an indication that, oh, it's wrong. It should not go to the 16.2. It will have some intelligence. It will give some pop-ups. So that's about this schematic drawing. So any doubts?